Hey, this is your U6A homework on solving quadratic equations by using the square root property, which means when you have a square, you can square root to get rid of it, and by completing the square. So there's times that you can do this, and there's times that you can do this. You do this if you have a trinomial. You do this if you just have an x squared, or you might have it completed, something like this in the problem. It's already been factored. So in these first four, you're going to do this first method, square root method. So to get rid of a square, use square root. This looks really blurry. Let me see if I can focus this. Okay, that's better. Go ahead and square root both sides. Put a plus minus in, and x is plus or minus 6. That's it. So on this one, you might be tempted to FOIL this, but don't. We can get rid of the square and then we don't have to FOIL. So we're going to get rid of the square by square rooting the left side and square rooting the right side, but we're going to be putting in our plus and minus on the right, and the square and the square root cancel, and you just get the radicand x plus 4. On the right side, you have plus or minus I radical 8. Now radical 8, if you do a factor tree, you have 3 2's, so 2 of them can come out. So one of them comes out, cross those out, and there's still a 2 left. So that would be 2i radical 2. Then the last step is to get x by itself, so we subtract 4. Now this subtraction of 4 could go at the end, but it's best to go in the front, in front of your plus minus. So you're going to write x equals negative 4, write that first, then followed by the plus minus, then the 2i square root of 2. That's your answer. So in this one, you've got a subtraction of 40, a multiplication of 8, and a square. So you're going to get rid of those three numbers one step at a time. First, add 40 to both sides. Then you're going to divide by 8. Now to get rid of the square, we square root. So you get x equals plus or minus square root of 5. And if I did a factor tree for 5, I actually couldn't do a factor tree for 5 because it's just 5 and 1. So that's your answer. So the next one, to get rid of a square, we're going to square root both sides, put a plus minus, and you get x plus 3 equals plus or minus 5. But we're not done yet because x is still not by itself. Your whole goal is solving for x. So we're going to subtract 3. And where does that go? I like it in front of the plus minus. So put this negative 3 in front of the plus minus. Now, if you don't have a radical, you should separate the plus minus. So this should be negative 3 plus 5 and negative 3 minus 5. So one of your answers is 2 and the other is negative 8. So notice we didn't separate in number 2, we didn't separate the plus or minus because 2i radical 2 is an ugly, not only is it imaginary, but you also have an irrational 2 here. So the whole thing, no need to separate here. Just leave it like this. And now if you wanted to separate, you could. You could write this as negative 4 plus 2i radical 2 and negative 4 minus 2i radical 2. You could write it like that if you wanted, but you don't have to. You only have to separate the plus or minus if this number right here is rational. That means no radical, no i's. Leave it like that. So this next step is like getting you ready. It's like you're a stretching exercise before you get to completing the square. This is a step of completing the square. So you're going to fill in a missing third term to create a perfect square trinomial. Then you're going to factor it as a binomial squared. A binomial square looks like this. So you're going to start with the trinomial and you're going to end up with this. So in order to get this term, it has something to do with this linear term. You're going to take half of 16 and you're going to square it. So half of 16 is 8 squared, which is 64. That's the perfect trinomial. Now, we're going to factor this trinomial as square root of x is x, square root of 64 is 8, and it's positive because it's a positive middle term. And another way to get to 8 is take half of 16. But no matter what, put a square on the outside, and that's called a binomial squared. I'm sorry about why this thing's so blurry. I don't know why it's kept going in and out. So what is half of negative 10? Hopefully you said negative 5. And what's negative 5 squared? It's 25. So when you factor it, take one of these, and then you can either take half of negative 10 Or you can take the square root of 25. It's the same answer, but the negative goes with the middle term. That's your answer. So what's half of 9? 9 halves. What's 9 squared? 81. What's 2 squared? 4. That's your perfect trinomial. How do you factor that? M plus, what's half of 9? 9 halves squared. What's the square root of 81 fourths? 9 halves. So half of negative 20 is negative 10. Negative 10 squared is 100. So half of negative 20 is negative 10. That goes there, or the square root of 100 is 10. So that's a binomial square. Now, solve each equation by completing the square. Your first step, you want to get all the x's, anything that has an x on one side, and then any number that doesn't have an x on the other side. Well, this one's already done for you like that. But I am going to rewrite this so that I can give a new space, kind of like what we did up here. We're going to try to complete this perfect square trinomial, and then that way we can factor it like this. So right now we have a 12 on the right side, but we're going to be adding something to both sides. Whatever you add to one side, you add to the other. So half of negative 4 is negative 2, and negative 2 squared is 4. So we're adding a 4 to both sides. Then we're going to factor the left side as a binomial squared. Square root of x squared is x. Half of negative 4 is negative 2. Square root of 4 is 2. 12 plus 4 is 16. And now we're going to solve it like we did up here. These two right here. Remember these two? So now to solve this, to get rid of the square, use square root. Two sides, putting in a plus minus. So then you get x minus 2 equals plus or minus 4. Add 2 to both sides. Where does this go? Mrs. Rollins likes it to go in front of the plus minus. So we're going to put the 2 in front of the plus minus. And notice there's no radical or no I. So we're going to split it up. So we have 2 plus 4 is 6. And 2 minus 4, which is negative 2. Those are your two answers. Having fun? Woo! Let's go. Let's do another one. Keep the x's here and subtract the 20 to the other side. So this one's going over here. What is half of 8? 4. 4 squared? 16. So half of 8 squared is 16. That's what we're adding to both sides. So the left side, if we factor it as a binomial squared, it's x plus 4 because half of 8 is 4, or the square root of 16 is 4. Negative 20 plus 16 is negative 4. This answer is going to have some i's because of the negative. Square root both sides, putting in a plus minus. X plus 4 equals plus or minus 2i. Then subtract 4 to both sides, put that in front of the plus minus. And I am not going to separate the plus or minus because of the I. 11. Now, I said I wasn't going to do one of these, but for those people in here that want to be challenged a little bit, actually, let's do 12 first. 12 is going to be easier. When you see a number in front of x squared, you cannot complete the square. You can only complete the square if there's a 1 here. I'm not saying you can't do it if it's not a 1, but it just makes it a little bit harder. So what I would do is notice that all of these are a multiple of 3. So let's start by dividing everything by 3. So we have this. So now it's easier already. You don't even have to worry about this 3 up here. This is what we're working with. So keep this on this side and subtract the 4 on this side. Now half of negative 3 squared is 9 fourths. Square the 3, square the 2. We're adding a 9 fourths to both sides. When you factor this, half of negative 3 is 3 halves. Squared, binomial squared. On this side, if you go to add, negative 4 plus 9 fourths, negative 4 plus 9 fourths is this. Math, enter, enter, is negative 7 fourths. And now we're going to square root both sides, plus or minus. So we're going to bring the I out, and we're going to separate the radical. 7 is not a perfect square, so it's going to stay under the radical, but square root of 4 is a 2. And then we're going to add 3/2 to the other side. And next is going to be 3/2 plus or minus I radical 7 over 2. If I wanted to, since they both have a common denominator, I could write 3 plus or minus I radical 7 over 2. What do you guys think about that? That's pretty hard, huh? So you're a math whiz if you understood that. And I think lots of you are math whizzes, so I think you guys are probably pretty good with that problem. Now this next problem's actually even harder than that one, so we're just going to do it. What the heck? We can do it. So let's divide everything by 2. So you get x squared minus 1x minus 3/2. So we have x squared minus x, and I'm going to add 3/2 to the other side. Now half of -1 is 1/2. If you square that, that's 1/4. So when you go to factor this, factors of x squared are x. Square root of 1/4 is 1/2. Half of 1 is 1/2. It's going to be a negative because half of -1 is -1/2. Now over here, if you add 3/2 to 1/4, you get 7/4. Square root. You get x minus 1/2 equals plus or minus square root of 7 over 2. Again, it's a 2 because there was a 4 in the bottom, and square root of 4 is 2. Add 1/2 to the other side. I'm going to put that in front. Get this? So this is fine with the answer, or you can write 1 plus or minus square root of 7 over 2. I like that. That's it.